So the official time will be around 8:05-ish. Just within that time, check in with your name so that we can see who's here. And I highly suggest sketching a unit circle. So put all the angles in radians and put all the coordinates. Make sure obviously they're in the right places. And yeah, so we'll officially get started at 8:05-ish. Alright, so let's get started around now. So, yeah, hopefully you have a unit circle of some sort drawn, and if not, well, we're gonna do that first anyway, so... Alright, the unit circle. So let's just start doing stuff on it. So if I were to draw an arrow on it here to represent a certain angle, this angle, by now we should probably be able to tell that this is pi over 6. I'm going to make that a bit thinner. Alright, so this is pi over 6. So, if you were to take this thing and then literally move it on here, then you can see that we have another angle here. So if we did that, then what do we have? We actually have pi over 6. How many times? 2 times. So this is 2 pi over 6, otherwise known as pi over 3. If you do that yet again, and I'm just going to keep a copy out here so that I don't have to keep copying things. Then, oops. Rotate it onto the circle yet again. We get another place. This is where we have how many pi over 6s? We have 3 pi over 6s. And that's equivalent to pi over 2. Alright, and then this pattern can continue over and over and over. And essentially, all those ratings that we get for the unit circle are these. We have the same angle repeated over and over. And the thing is, this works for every single angle except for the ones that are directly in between all of them. So notice we have not yet done anything with these. We haven't had any angles actually hit those. But essentially, we just keep getting angles that are on all the other parts. So this is an interesting little pattern right here. We see that just using the pi over 6s, we're able to get a lot of the angles, but not all of them. So we get pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, and then 6 pi over 6, which is just pi, right? If we continue doing that, we'll get these all. So basically, again, everything except for the middle parts. So then we get 7 pi over 6. We get 8 pi over 6, which is the same as 4 pi over 3. And we get 3 pi over 2, because that's 9 pi over 6. Reduces to that. Then we get 10 pi over 6, which reduces to 5 pi over 3. I'll draw that more like here. And then we get 11 pi over 6, which does not reduce. And then here we started with 0, and it also is 2 pi. So it's helpful, and you should probably realize that those are both the same thing. So, if I were to erase these, basically, we have a lot of the angles. Not all of them, but a lot of them. All except for 4 of them. So remember, this one is pi over 6. If you were to divide that in half, then we get 3 pi over 6. So 6 pi over 6 is pi. Divide that in half, get 3 pi over 6, which is pi over 2. That should make sense. And then we divide that in half, and then we get this. This is directly halfway between pi over 2 and 0. So if we have a half of pi over 2, we get pi over 4. So this is pi over 4. And we can do stuff with it. So I'm going to get rid of that arrow first. And then now we can focus on this arrow. So let's do the exact same thing with it. I mean, based on literally what we just mentioned, it should make sense that if we have two of them, we just end up at pi over 2. So there we go. Shouldn't be a surprise. Okay, well, if we do it again, then we end up at a different place. Obviously, at a different place. Where do we end up? We end up over here. And then do it again, and we end up at another place, which is over here. So that's pi over 4. And then this, we already kind of established that that is 2 pi over 4, which is going to be pi over 2. And we go another one over here, and then this is going to be 3 pi over 4. And I go another one, then we have 4 pi over 4, which equals the same thing as 6 pi over 6, in other words, pi. And then we go again, here, we're going to get 5 pi over 4. We go again, we get 3 pi over 2, so that's 6 pi over 4. And then we get to 7 pi over 4 here, which does not reduce. And then 8 pi over 4, otherwise known as 2 pi. And we started at 0. So I'm just going to erase these and write them better, because next we're going to go into the coordinates. But essentially, that's the pattern that I want you guys to be able to get. If you just memorize the angles, it makes things a lot harder than they need to be. Yeah. So if you realize that all you're doing is getting multiples of pi over 4 and pi over 6, and you know where they go, and visually it's pretty clear where they go. So if it looks like something should go somewhere, it probably should. As long as you know what you're doing. And for me, whenever I draw my unit circle out, I kind of just think of all those multiples the entire time, rather than thinking, okay, I get 2 pi over 3, then 3 pi over 4, then 5 pi over 6, then pi. Very few mathematicians actually do that. Normally, we just kind of process this in our heads based on those patterns. So in a way, basically, no one really ever memorizes a unit circle, except, I guess, kind of high school students. But the easiest way is just know the pattern, do it out. And that'll also help you with your arithmetic. / force you to be able to do it. Alright, so just a quick little summary. So for all the angles that are not at the 45-degree marks, so that's these ones, they are all multiples of pi over 6. Multiples just means you can multiply something to pi over 6, and then you can get it. So I put this notation k pi over 6, where k is an integer. So remember, we've gone over that in class before. And then all of the 45-degree areas, those markers are all pi over 4s. And compass corners, that just means up, down, side, side. Because north, south, east, west. That whole thing. So the x and y axis, basically. Those are all integer multiples of pi over 4. So how about the coordinates? They have these patterns. Basically, at the pi over 6s, you always have square root of 3 over 2, comma 1/2. All of the pi over 4s have 1 over square root of 2, comma 1 over square root of 2. And all the pi over 3s have 1/2, comma square root of 3 over 2. And it's not too difficult to remember them, because the pi over 6s, they're all going to look like this. They're all going to be 30, 60, 90s, where the base here is a lot bigger than the height. And square root of 3 over 2 is bigger than 1/2, because square root of 3 is about 1.7, right? We talked about that in class. If we divide that in 2, that's definitely bigger than 1 over 2. So if you have this triangle no matter what, you're going to know that you're going to have square root of 3 over 2 and then 1/2, because those are the only, look, there are only 3 special values: square root of 3 over 2, 1/2, and 1 over square root of 2. Aside from the ones, but the ones are pretty obvious where they are. So if you remember it that way, that'll help you with the pi over 6s and the pi over 3s. Because the pi over 3s are the exact opposite, where the smaller side is on the x-axis, and the y-axis you get a bigger value. So that'll be square root of 3 over 2, and then 1/2 as the x's. And then for the pi over 4s, we get a 45, 45, 90. Remember, their base and their height are the same. So what that means is we have 2 of the same values. And you only ever have 1 over square root of 2 when you have the same values. So using that, we can easily just write all the coordinates for this. So I'm just going to do that real fast.